So Booleans, there are exactly two Booleans in this language, and they are true and false. So hooray, we got that right. We have strings. Does anybody know why they're called strings? Anyone?
The chains of characters?
Well, it turns out nobody knows.
Okay.
The first place I've been able to find in the literature that refers to a specific data type, which is a sequence of characters, is the Algol 60 report. But there's nothing in that report which explains why they chose the word string. I mean, the first time you encountered it, you must have thought, well, this is strange because it doesn't look like a piece of string in any way. So how'd that happen? I asked John McCarthy, who was on that committee, he was the inventor of Lisp, why did you call it strings? And he said, well, Klana was doing this stuff with strings of symbols. He said, but that didn't really answer the question, because at the time of the Algol 60 report, they would talk about strings. A block was a string of statements. So when did it become specifically a string of characters? And he was really annoyed that I was asking him a question he didn't know the answer to. So that was the end of that conversation. And then he died, and he was the last survivor of the Lisp committee, so we'll never know, or of the Algol committee. So anyway, we got them, and we call them strings. And I think we call them strings because there may have been some CPU architecture which linked characters together to make stringed sequences of characters. And I think that because what's the operation we do on strings? It's concatenate. But concatenate means to form links. It's an operation in chain making. So you would think if it's strings, it should be tie or maybe slice or wind or something that strings do. So we've got some mixed metaphors going on. So I'm still searching the literature, trying to find out where strings came from, but I haven't found it yet. So anyway, we got them. We got strings. A string is a sequence of 0 or more 16-bit Unicode characters. It's characters in the sense of UCS2, not UTF-16, because there's no awareness of surrogate pairs. At the time that JavaScript and Java were designed, Unicode was going to be a 16-bit character set. It later grew to a 21-bit character set, and JavaScript is not aware of that. There's no separate character type. Characters are represented as strings with a length of 1. Strings are immutable, which is good. Once you make a string, it cannot be changed. It's fixed for all time. You can make new strings by concatenating together bits of old strings, but you cannot change a string once it's made. Similar strings are equal, which is great. Java got that wrong. JavaScript got that right. Hooray for JavaScript. String literals can use single quotes or double quotes with escapement. Both work exactly the same way. No magic quotes or quasi-quotes or anything like that. But there's no reason to have two ways to make strings, but we do. So given that, I recommend use double quote for external strings, strings that make sense outside of the program, like URLs and templates and notes to the user, that kind of stuff, and use single quotes for internal strings, like the names of properties and character constants, stuff like that. There's nothing that enforces that, but I think it's a good convention. We can convert a number to a string by using its toString method. I prefer instead to use the global string function, which does the same thing, and will also work better on things that do not have toString methods. We can convert a string into a number by using the global number function or by using the plus prefix operator, which I prefer. We also have a parseInt function that I don't like. ParseInt is something that was borrowed from Java. It will convert a value into a number, but it stops parsing at the first non-digit character. And it won't tell you where it stopped or why it stopped or what was left over. And you usually want to know that because that can be important, but it doesn't give you any clue. There was a big design error in that if the string you were parsing starts with a 0, it assumes that you meant that to be parsed as base 8, octal. And so if you're parsing something like a date or a time, which might have an 08 or an 09, that will be parsed as a 0. because it sees the 0 goes into base 8. It sees the 8, says you are not an octal digit, so I stop here. You can get the 0. Yeah. So because of that, I recommend you always include the radix argument, which says base 10, we're on planet Earth, damn it. You know, base 10, 0 to 9. Strings have a length property, which tells you how many 16-bit characters are in the string. Surrogate pairs will be counted as 2 characters in that count. Strings are objects, and so they contain a big mess of methods. I'll let you look them up offline, but there are a lot of them. Many of them are actually very useful. Every string inherits from string.prototype. So if we wanted to add new strings to or new methods to strings, this is the place where we could do that. Again, this is not something applications can do, but this is how we've been growing the language.